Next up, it's just a small topic, creating the internet of your things. We have Sam George, Director of Azure IoT. Please welcome Sam.
Ooh, good music. Good morning. Super excited to be here. My name is Sam George. I am the Director of our IoT efforts at Microsoft for Azure. What an amazing industry to be a part of. I thought Jack did a great job illuminating some of the opportunities and how IoT is going to transform the planet. We're seeing some incredible momentum in IoT. Just last year, or just 5 years ago, it looked a lot less than it does now. And what that really comes down to is that the next wave of computing is here. When you step back and think about how computing has evolved over the last several decades, we started with the mainframe and then went to PCs and then the proliferation of smartphones. IoT is just the next logical evolution of that. And IoT enables us to take advantage and sense the real world in ways that were never possible before this. If you look at the forces that are driving this, of course, Moore's Law continues on its relentless pace, increasing transistor density. Kumi's Law, processing power, the amount of power that it takes to run all those transistors is decreasing, meaning that now you have opportunities to place IoT devices in far-flung locations with batteries that last for years and years. And then Metcalfes Law, the value of a network is proportional to the square of the participants. Of course, is very interesting in IoT. And one of the reasons I love to talk about Metcalfes Law and IoT is that, like you've been hearing today, the value in IoT comes from combining insights and data. There's a lot of misconception, I think, in early IoT that all of the IoT devices on the planet would somehow magically start intermingling with other IoT devices and communicating in ways that we don't quite understand, but which would do something profound. That's kind of not the way things are shaping up. The way things are shaping up is that there's trust boundaries in the world of devices. My favorite example with this is that your home automation system doesn't go commingling with your neighbor's home automation system behind your back. There's trust boundaries. The trust boundaries tend to happen at the data level and the insights that are gained at the data level. And of course, all of this is about achieving business results with IoT. People don't wake up one morning and decide, I'm going to go buy a bunch of devices and provision them and place them in locations just for fun. You do it for a reason. You do it to transform your business, to achieve operational insights, to be able to do predictive maintenance, to be able to improve your businesses and the experience of your customers. And so harnessing the IoT revolution starts small. It starts simple. And we see that the IoT space right now is in its early phases. There's certainly some big projects that are happening, but a lot of companies are just starting on their IoT journey. IoT is very much a new normal. It's here, and there's customers that are benefiting from it already. But it's not a new normal in terms of mass appeal yet. Customers are still getting their heads around IoT. So I thought I'd like to talk about how IoT gets started. For us, it all starts with a great idea. What if my things could tell me when they go someplace they shouldn't? What if my things knew when they were going to break before they did? What if I could tell when it's the best time for my thing to power down, power on, alert me? What if I simply knew where my things were? One of the things I love about being part of this industry is watching all of the IoT solutions get adopted. And I'm still surprised how many IoT solutions right now are simply about knowing where my things are, be it my pets, be it my jet engine aircraft holders, be it my trucks. There's a lot of these projects just knowing where things are, and it's a great way to get started. And it's surprising how much business value there is in just that. What insights could I find from the data from my devices, combined with other data from other devices, combined with other data that I already have in my own business? And then what if I could use telemetry and data from my devices to improve new generations of things? And of course, this is where it starts to get really interesting, because things are rarely made up of one thing. They're typically composite. And so if I have a jet engine aircraft, that's made of multiple parts. And all of those parts play a role in predictive maintenance for that. Next comes a device. And getting a device, figuring out which device you're going to use, which one to choose, which software to use, which operating system, which language you're going to use. There's a lot of choices that are here. And then data from the device and where you choose to send that data. And of course, securing the device. This is a really important topic in IoT, and I know everyone's talking about it. It's incredibly important to secure devices for IoT. There's a lot of frightening exploits that you see happening in the industry right now. And quite frankly, a lot of those are happening in places where people aren't following hardware best practices and security best and software best practices. There's a set and a state-of-the-art in IoT for hardware best practices and software best practices that includes things like secure boot, that includes things like secure attestation and identity, that includes things like secure communication and protocols, the ability to update software remotely. Things like that are very important in securing IoT. And so if you're a things company coming from the world of things and moving into IoT, it's important to take this into consideration. It's important to secure your things. Insights from that data, to be able to find the insights that are going to power new businesses and new opportunities. And how do you do that, and where do you get started? And then, of course, you start getting an increasing number of devices and monitoring lots of devices and data, and monitoring all of that data in real time. A traditional pattern that you see in IoT is collecting data, finding insights into that data, and then once you have, monitoring telemetry streams in real time and being able to track across millions of devices and looking for those patterns that indicate something interesting from your devices. And then it's not enough to just find an insight once. Devices and the world around you changes frequently, and so you're constantly updating your insights and updating the real-time processing that you're doing over that data. And then a very important topic is that around device management. We talk to customers and they get to several hundred or several thousand devices, and if you're not able to remotely control and update the device software on those devices, if you're not able to push configuration, if you're not able to do inspection and to find out and do diagnostics work, then IoT starts to become very difficult. If you have to roll a truck every time it's time to update software, then you're not going to have a great IoT experience. So you need the ability to be able to do this remotely, safely, and securely. Visualizing and managing all of the services that are in operation. There's a lot of services that come into play in IoT, from cloud gateways to storage to analytics, and being able to monitor and manage all of those. Integrating all of this into your existing businesses as well. So if you're monitoring things in real time and one of those things goes into a place it shouldn't, what do you do about it? There's business process integration that's a very important component in IoT. So there's a whole set of things that you have to do. And of course, by its very nature, IoT is very much a global phenomenon. Most customers, if they're not already looking at a global deployment, will be looking at global deployments. And the last thing that you want is one solution on one part of the planet and another solution on the other part of the planet. You want to be able to simply configure and monitor and manage those worldwide. So IoT is awesome. It's very promising, it's here, and it's going to transform our world, but it can get complicated quickly. So wouldn't it be great if someone simplified this for you? And that's why we're here. So there's two things I want to highlight. Number one, at the IoT operating system level, Windows 10 IoT is an amazing operating system for IoT. It has state-of-the-art security features, from secure boot to secure hardware IDs to all of the rich security service that Windows has had built in over decades. Automatic connectivity to Azure, to sensors and rich peripherals that, of course, Windows supports, and, of course, support for the universal Windows platform. Now, Azure IoT is very much cross-platform. We work with any operating system, any device across the planet. But I think when customers start to think about the total cost of ownership across all of their IoT devices, you realize that Windows 10 is a very compelling IoT operating system. So the thing that I work on as well is the Azure IoT Suite and Azure IoT. So what we're doing with the Azure IoT Suite is to simplify all of this, all of the complexity, to provide an experience where customers can get started in minutes and yet still customize to meet their needs. And it's important to do both because no two IoT solutions are exactly identical. And you don't want to have the first step in your IoT journey, especially if you're a thing company, to be hire a software vendor. End-to-end pre-configured solutions. So as we were working with early adopters and partners, what we found is that there's patterns that you see again and again and again in IoT, remotely monitoring devices, doing predictive maintenance, managing assets. And so what we did is instead of having to build those every time with customers or to have customers build those based on reference guidance, we now provision that as part of the IoT Suite. So you can go to AzureIoTSuite.com, you push a button, and in 5 minutes you have a working end-to-end IoT solution that scales to millions of devices. Very, very important. And then, of course, a broad set of ecosystem around that, and I'm going to talk about that. When we think about simplifying IoT, we think about IoT Suite being built on 3 pillars, and really any IoT solution being built on 3 pillars. The first one that's very important and present in almost every IoT solution that we see is around device connectivity and management. This is very important. You have devices to provide the care and feeding for. We have a service called Azure IoT Hub, which is an at-scale service, globally available, handles millions and millions of devices, and it does telemetry and command and control. It handles secure protocols, supports all of the protocols in IoT today, the popular ones, HTTPS, AMQPS, MQTT, of course. We build open source software that's available on GitHub under MIT license, runs on multiple versions of Linux, ARM embed, FreeRTOS, iOS, Android, Windows. We run on anything with multiple languages, Java, Python, Node, C, C#. And we just recently announced our Gateway SDK. One of the things I want to highlight, especially around the topic of device connectivity and management, is that there is very much a balance in terms of edge and cloud in IoT. We're not starry-eyed and think that every IoT device is just going to connect to a cloud and send its data. In fact, most of the time, what you see in IoT is that edge is very much in play in IoT, and there's traditionally gateways or trees of field gateways that are doing simple things like filtering, store and forward, security isolation, and things like that. So to enable this, we also have an open source SDK that we just recently made available on GitHub, our Azure IoT Gateway SDK. Runs on multiple versions of Linux and Windows, and we'll just keep adding support as customers drive us towards. And then the last thing that's very, very important in all of this device connectivity and management is our device management story. So built on open standards of OMA LWM to M, our device management allows you to manage the software, firmware, and configuration on any device running any operating system. This is a very, very, like I was explaining earlier, such an important part of IoT is being able to manage the life cycle of these things and manage them in a way that makes sense to your business. So part of what we're doing with our device management is including rich topology support so that you can store topologies in the cloud. My favorite example is if you're doing building management and you want to do something where you're tracking the number of people that enter a building and then bringing up lights when they're in. You don't think about device management in that scenario in terms of, I have 723 devices and actuators in this building. You think about it in terms of buildings with floors, with rooms, with sensors. And when you update based on subtopologies. And you have to coordinate between your operational technology teams and your IT teams and have set windows. And our support is built around that notion and includes support for topologies and update windows and things like that. Very, very important. The next pillar that IoT Suite and all these IoT solutions are built on is around analytics and operationalized insights. There's a lot of value, like we talked about, in just knowing where things are. But really, the interesting part of IoT is around insights into data and how you combine those data insights with other data. For this, Microsoft builds the Cortana Intelligence Suite. another globally available service or set of services for finding the deepest insights into your IoT data and making it super simple. This includes things like machine learning, our recently announced bot framework, our cognitive intelligence APIs. And then, of course, part of IoT, and a very important part, is where you're going to store all that data. So we have Azure Data Lake, which is an infinite size data storage capability. It was originally built for Bing to store the index to the internet and to be able to update it frequently at petabytes per day. And so Azure Data Lake is purpose-built for IoT. And then, of course, to be able to do stream processing over those millions of telemetry streams from those billions of devices. We have services today, Azure Stream Analytics for finding those insights, and Azure HD Insight Storm. I like talking about Storm because it's part of our commitment to open source. This is a hosted offering of Apache Storm. Some people are still of the opinion that Microsoft Azure is a Windows cloud. It's very much a Windows and Linux cloud. Linux is one of our fastest growing workloads, and we support many, many versions of Linux, including Apache Red Hat. Including Red Hat Linux. We also support many hosted offerings of open source services from the Apache Foundation. So we're super excited about the adoption that we're seeing in Linux, in Azure. And then, of course, the last area is around presentation, managing all of this, and connecting it to your business. And for that, we have rich services like Power BI, Azure App Services for websites, mobile services, API management, logic apps for connecting into your business. And of course, this isn't just about connecting into the business offerings that we offer, like Dynamics, but also lots of rich third-party ones, like SAP and Salesforce. We are very much an open cloud. And then these pillars are really built on a foundation on a world-class foundation of a hyperscale cloud that we're on track to be available in 30 regions worldwide. That's enterprise proven with the largest number of compliance portfolios. When you decide that it's time to do business in IoT and you pick a cloud, if your business requires one of these compliance requirements, it's very important to know which cloud supports those. A rich data and analytics ecosystem, including the Cortana Intelligence Suite. And then a huge focus in hybrid and on-prem. This is one of the ways where, frankly, we differentiate from our other cloud vendors that we compete with. And this is a huge focus on hybrid and on-prem. Much like I was talking about the edge of the network in terms of gateways, we also recently announced support for something called Azure Stack, which is being able to run Azure itself on premises in your own data centers. And so we are working to make all of our IoT offerings available on premises as well. This is really important because there's some situations where you need local control. If you have a remote oil rig and you need local control that's figuring out whether it's time to shut down that oil rig, you don't want to rely on the satellite connectivity or a potential fiber cut to make that decision. You want to have local control. And so local control in IoT is very, very important. And this is part of our commitment to it. And then, of course, end-to-end security and privacy. We as a company have very much embraced this over the years. We have learned how to be secure by default. And we take privacy incredibly seriously, as I hope you've seen. And then last, a rich and open ecosystem. I hope what you're hearing is that Microsoft is very much committed to the open source community, to open standards and interoperability. So let me talk about some of those things. This is an important part of IoT as well. IoT, in our opinion, is very much an ecosystem play. It is not a winner-take-all game. The whole world is going to be doing IoT. And so interoperability and openness is very, very important for IoT to enable customers and partners to get the most value from it. We are part of all of these open standards and consortiums. I'm going to talk about a few. So we're part of the Open Mobile Alliance for our LW M2M support. This is what we use for device management. We did not go reinvent a new device management protocol. Instead, we're using standards. We're part of OASIS for bringing MQTT forward. MQTT is a very, very popular protocol in IoT. We fully support it, and it's evolving, and we're being part of that evolution. Of course, the Industrial Internet Consortium and the Internet Engineering Task Force, the Open Connectivity Foundation to make it easy for devices to communicate with other devices and with the cloud. The Open Fog Consortium, which is something that we joined with a broad set of partners to define the patterns that will be standard between the edge and cloud. The Eclipse Foundation, of course, and the OPC Foundation. OPC Foundation, I'll talk about this just a little bit, is a really important one. The OPC Foundation is devoted to open connectivity between the world's 37 million already deployed industrial devices. And so we recently announced support that we've contributed back to the community for OPC UA support for both Windows 10 and Azure IoT. And this is very important. We just announced this over at Hannover Messe in Germany a few weeks ago, because this allows connected factories to suddenly now be able to connect to the cloud in a secure way and to be able to see all of the data coming from their factories and run rich analytics on it. To the Eclipse Foundation, we contributed Cura connectors to their Cura Gateway project. And then, of course, we have our open source device SDKs and gateway SDKs. And then we're also contributing to the Open T2T Foundation, the Open T2T project. And this is about interoperability between data formats and schemas. And we will continue to join more of these consortiums and standards and contribute more open source where the mass of the industry starts playing. I want to highlight all of this in terms of an actual customer of ours, which is Rolls-Royce, and what they're doing with IoT, and let them tell the story for us.
As an airline pilot, I know that to fly with the best, you need to work with the best. With over 13,000 engines in operation around the globe, Rolls-Royce provides the services to maintain them at peak performance. Today, each engine has thousands of sensors that can produce terabytes of data on long-haul flights. Making sense of all that data is critical in transporting my passengers safely and efficiently. Rolls-Royce uses Azure IoT Suite to analyze data remotely and deliver real-time, actionable insights to me and to the airlines about engine performance and operational efficiencies. Advanced analytics help us optimize fuel economy, anticipate maintenance needs, and avoid costly downtime and delays. A single unscheduled disruption and its knock-on effect to a fleet and the passengers can cost an airline up to $1 million a day. With early notice, our team can proactively have parts at the right place and time, reducing inventory costs and maximizing availability. Up to 1/3 of a plane's weight is fuel. As a pilot, I decide how much fuel my plane carries. Insights into engine efficiency, weather conditions, flight path, and scheduled landings impact my decision. Cortana Intelligence helps me choose the optimal fuel level to maximize efficiency. With 40% of our operating budget devoted to fuel, even a small percentage reduction can save us tens of millions of dollars each year. Microsoft and Rolls-Royce, reaching new heights in customer value.
So we will, can you go to the next slide? We will be here all week, actually one back. We will be here all week. We're honored to be a part of this. We look forward to coming to these year after year. Thank you for your time. We really appreciate it. We'll also be over in booth 624, and I'll be around today if folks want to talk. So thank you for your time. I appreciate it. Have a great day.